Welcome to This Explainer. Today, we are gonna virtually void the warranty and completely tear down the 2026 VR headset ecosystem to see exactly what makes these modern spatial computers tick. Now, if you're still picturing those clunky, heavy, neck-straining headsets from just a few years ago, well, you are in for a serious treat because the technology has evolved at an absolutely breakneck pace.
Here is our agenda for the teardown. 1. The visual paradigm shift. 2. Engineering the Holy Trinity. 3. Global ecosystems. And finally, 4. The expert selection matrix. All right, let's jump right in.
Section 1. The visual paradigm shift, or seeing is believing. We are kicking things off with what your eyes are actually experiencing. Because those bulky, low-resolution tethers of the early 2020s, yeah, they are officially ancient history. We have fully entered the era of true spatial computing. Okay, get a load of this staggering metric, 4,000 pixels per inch. Thanks to the massive industry shift toward Micro-OLED and Micro-LED displays, which give us true per-pixel illumination and basically infinite contrast, we are hitting pixel densities that totally eradicate the dreaded screen door effect. You know that feeling? Like you were exploring virtual worlds looking through a literal screen door? Gone. Completely history. But here's the thing. To truly measure this retinal resolution, hardware engineers don't just look at PPI. They use this beautiful little mathematical formula to calculate pixels per degree, or PPD. It basically takes the horizontal pixel count, divides it by the field of view, and adjusts for lens distortion. And here is the absolute kicker. Current 2026 flagships are already exceeding 50 PPD. When you consider that 60 PPD is roughly the threshold of human visual acuity, your eyes are literally running out of things to complain about. Which brings us to the next major breakthrough. We are finally solving the Vergence accommodation conflict, or VAC. In plain English, earlier headsets basically forced your eyes to converge on a close virtual object while physically focusing on a screen that was permanently fixed just inches away. Your brain absolutely hated this. It's exactly why older VR could make you feel so incredibly motion sick. But 2026 optics use meta-lenses, these tiny sub-wavelength nanostructured arrays, to create dynamic varifocal displays. They physically or optically adjust the focal plane in real time, which honestly is just a highly professional way of saying the hardware finally stops you from wanting to throw up. Section 2. Under the hood, engineering the Holy Trinity. Let's virtually crack open the casing and take a look at the cutting-edge silicon making all this magic happen. Modern headset engineering has totally shifted its focus. It's no longer just about cramming in the brightest, sharpest screens. It's actually about perfectly balancing a highly complex set of core engineering challenges. So the crucial takeaway here is that every single 2026 headset lives or dies by this holy trinity: thermal management, computational latency, and spatial awareness. To handle all of this without literally catching fire, the industry standard is now a heterogeneous dual-chip architecture. You've got your main application processor running the game or OS, paired tightly with a dedicated spatial coprocessor. You can kind of think of that coprocessor as a heavily stressed-out data wizard whose entire existence is just wrangling a massive fire hose of data from over 10 onboard cameras, LiDAR scanners, and IMUs, all at exactly the same time. And you know what? It does its job incredibly well. Wait. Motion to photon latency of less than 9 milliseconds? That is practically predicting the future fast. Seriously, just a few years ago, 20 milliseconds was considered totally acceptable. Now, through insanely clever tricks like late latching and asynchronous time warp executed entirely on that spatial coprocessor, the delay between you moving your head and the screen actually updating is basically imperceptible. But how exactly do they push all those millions of pixels without completely melting your face? Well, by tracking your eyes. Modern headsets use ultra-low latency infrared sensors, tracking your eyes at up to 240 Hz to enable dynamic foveated rendering. It acts exactly like a tight theater spotlight, rendering only the tiny specific area where your fovea is currently looking in full, crisp retinal resolution, and heavily dropping the resolution in your peripheral vision. This brilliant little trick slashes GPU workloads by an incredible 70%, saving massive amounts of battery and thermal overhead. Moving right along, Section 3, Global Philosophies, the Ecosystem Wars. Let's zoom out from the bare silicon to look at the broader global tech Cold War. Because in 2026, where your headset is designed completely changes how it operates. Purchasing decisions are no longer just about reading down a spec sheet. They are now deeply tied to geographic and corporate philosophies. Let's start the world tour right here in the Americas. We're looking at a massive clash of titans here. On one side, you have Meta, who continues to heavily subsidize their hardware costs to democratize what they call an openish mixed reality world, leaning super hard on the open XR standard. And on the exact opposite end of the spectrum, you have Apple's strict premium walled garden. Apple is hyper-focused on extreme high-fidelity pass-through and seamless integration with their iOS and macOS ecosystem. In fact, their corporate philosophy absolutely refuses to even say the word VR. They strictly position their devices as spatial computers. Meanwhile, across the pond, European manufacturers like Varjo are building slightly paranoid but absolutely excellent enterprise-grade headsets. They focus heavily on 70-plus PPD bionic displays, and crucially, they take GDPR incredibly seriously. Because eye tracking and pupil dilation can actually reveal your cognitive load and emotional state, European headsets are designed to process all that biometric data entirely on-device with zero cloud exfiltration. On the flip side of the globe, Asian manufacturers dominate in sheer hardware agility. They're pioneering rapid miniaturization, using novel silicone anode batteries to drastically drop headset weight, while companies like Sony are pushing deeply immersive, localized haptic force feedback right into the headset itself. Section 4. The Expert Selection Matrix. Future-proofing. Now let's bring all of this highly technical, professional knowledge together into some really actionable advice for your next upgrade. We've distilled the entire analysis into an expert selection matrix, so you can perfectly match your specific use case with the right architecture. If you're doing high-end enterprise design or simulation, you definitely still want tethered PCVR, or at least Wi-Fi 7 wireless, pushing that bionic 60-plus PPD resolution. For consumer gaming, standalone devices weighing under 350 grams with robust inside-out body tracking are the absolute sweet spot. And for spatial productivity, you want to hunt for standalone devices with zero latency pass-through and highly refined hand and eye UI navigation. But to truly future-proof your investment, there are 3 absolute non-negotiable demands you should make. First off, prioritize OpenXR compliance so your software library doesn't get totally locked into a dead ecosystem down the line. Second, it's time to ditch the clunky old tracking base stations. Inside-out SLAM, that's simultaneous localization and mapping, using integrated depth sensors is absolutely the way forward. Finally, insist on devices with automatic dynamic IPD adjustments driven by eye tracking. It guarantees immediate visual comfort, which is a lifesaver, especially if multiple people are sharing the exact same headset. So, the 2026 ecosystem has successfully crossed the chasm. It's pretty much eradicated the visual and physical discomforts of the past, but honestly, this leaves us with one final incredibly provocative thought. Now that our screens are effectively matching the biological limits of human vision, what's next? Are we simply biding our time until we ditch the displays entirely for direct neural interfaces powered by 6G edge computing? The headset is no longer just a display. It's a computational engine bridging realities. The only question is, are you ready to plug in?